Hello and welcome to today's demonstration on the impact of different magma viscosities on eruption style and damage patterns. Let's take a look at today's model. Today's model consists of a variety of structures and elevations. In the center, we have the volcano. Directly next to that is a small valley leading to a house. We have a castle in a low terrain area but outside of the valley. A relatively high terrain area with some vegetation and a couple of houses. An apartment complex directly next to the volcano on slightly elevated terrain, and a distant mountain with about the same elevation as the volcano. We will be assessing the difference in damage pattern and eruption style for two different viscosity magmas. In orange, we have a high viscosity magma. Notice how thick and pasty the orange substance is. In green, we have the low viscosity magma. It is much more water-like and runs a lot easier. For the eruption simulation, I will be loading each type of magma into this volcano's magma chamber and attaching this bike pump to the bottom tube to simulate gas entering the volcano. We will then observe the difference in damage and eruption styles for the two different magmas. First, we will test the high viscosity magma. Notice that more force and air is required to erupt the magma from the volcano. Let's take a look at the damage. Pause the video here and take a few moments to describe what you saw. What structures were hit? Were they low or high elevations? Was the damage specific or more generalized? After you pause the video for a few minutes, pair up and discuss your results with a partner. Next, we will test the low viscosity magma. For this eruption, less gas and force will be needed to erupt the low viscosity magma out of the volcano. Let's take a look at the damage pattern for the low viscosity magma. Pause the video for a few minutes to discuss the differences between the two damage and eruption styles for the two magmas. After looking at the results, it becomes evident that the high viscosity magma is more explosive when erupting and damages a much more broad region of all elevations than the low viscosity magma. Notice that in the low viscosity magma, the magma flowed out of the volcano. Super low elevation areas like this valley were especially impacted by the low viscosity magma. Despite being directly next to the volcano, these two areas of high elevation were almost unimpacted completely by the low viscosity magma. This is because of its tendency to flow rather than erupting through the air like the high viscosity magma. Thank you for watching.